afternoon, everyone. Welcome to Data Warehouse Back to Basics, Dimensional Modeling. That's a tough word to say, isn't it? It's great to have you with us this afternoon. Thank you. My name is Lori Blandford. I'm the Marketing Manager here at Dun Solutions Group, and I'm your moderator for today's presentation. And our main presenter is our Business Intelligence Superstar, Jose Hernandez, Director of BI. And we're very excited about today's presentation as it is the first webinar in this new Data Warehouse series. And Jose is going to speak more about that in just a couple of minutes. I do want to make sure everybody knows how to submit questions in case any arise during the course of the presentation. Please feel free to submit via the box on the lower right-hand corner of your screen. That's the questions panel. And we'll see those throughout the presentation. And any time that we have left at the end, we'll be able to address as many as we can. All right, so we're going to do a very brief introduction of Dun Solutions Group. All right, we were founded 24 years ago, and we are a full-service information technology consulting firm. We design, develop, and deliver a wide range of solutions using a variety of advanced tools, and we deliver those solutions worldwide with offices in Chicago, Minneapolis, Raleigh, and Bangalore, India. Our offerings fall into three main practice areas: application development solutions, and this includes custom app development, mobile app development, e-commerce, portals, and web design; business intelligence solutions, which includes end-to-end BI solutions, dashboards, reporting and analytics, mobility, and other advanced BI capabilities; and then package solutions, and these are software and services offerings for specific vertical markets or unique needs. In addition, we do offer training solutions across these areas that include classroom, on-site, virtual, and custom training. Our clients include some of the biggest names in American business and many mid-market companies, as well as a large number of government agencies. Some of these customers include PepsiCo, Abbott, Bank of America, Kaiser Permanente, Allstate, City of Chicago, Progress Energy, and many others. To offer our clients the most advanced solutions possible, we maintain several close partnerships with industry-leading technology companies, and those include Microsoft, IBM, and SAP Business Objects. All right, at this point I'm going to turn it over to Jose. I know he's very eager to get started, and I hope everyone enjoys the presentation. Thank you.
Good afternoon, everyone. For many of you, I've recognized a whole bunch of names. Welcome back. And thank you for your all continued support in our series of webinars. Today marks the beginning of a new series. For those of you who have been with us, you've gone through our SAP Business Objects series of webinars where we basically dissected a variety of tools in the SAP Business Objects stack of tools. What we're doing in this new series is a little bit different. Our primary focus is on data warehousing, and our intent here is to stay tool agnostic with a Kimball focus. And we will, through the series of webinars, be looking at the entire BI stack from the backroom activities and a little bit into the front room activities. One can consider the previous series webinar front room activity, and that was the case. So this first presentation is really getting back to basics, and the one thing that I wanted to do with the very first webinar is to make sure that we had a common understanding of the terminology and concepts that we were going to talk about and look into through the entire series. The idea is, for some of you, this might be a repeat. You actually might find a few things that you were not aware of that you might want to look into. And there's also a few technical components which basically focus on some of the approaches and techniques for doing dimensional modeling. And what I wanted to do with this series is make sure that we kept it fundamental. There are variations and things throughout implementations that you might do, but I wanted to make it a little bit academic in terms of let's start with the pure discussion of what these concepts are, and then in future series and in future webinars we can get a little more tool specific with some of these things. All right, so we did drink or sip, I should say, Kimball Kool-Aid. So those of you who have been around Data Warehouse for a while certainly will notice that the slant is a Kimball slant as opposed to an Inman slant. I'm going to take a time out here a second. I see there's some questions popping in here. And the very first question, we may as well say this during our introductions from now on. Yes, the slides will be made available, but even better, we record these sessions, and there will be a link to relive the session if you wish to do so, or share that with folks that didn't get a chance to see this, that you know might want to see this. All righty, so let's get started here a bit. And the first thing I want to do is I want to set the stage and basically, so why do we build data warehouses? What's the importance of these things? Because fundamentally, all this work that we're going to talk about and do, there better be a purpose to it. And the reality is that we've acquired mountains of data over the years with the various systems that we've put in place. And so with all this data that we've acquired, we certainly want to make sure that we can do something with it. So this data, we have to be able to basically provide access to this information to our business users, and in a very simple way. I don't expect my business community to learn SQL or to know how to read entity relationship diagrams. I want to get all this data from all these systems in a consolidated location where they can make business decisions. Ultimately, that's the point for doing all this. Okay. So let's talk about the systems that we have in place today. And we have operational systems out there, systems of records that are typically built with database structures underneath them in what's called third normal form. Third normal form is wonderful for recording transactional type of data. It's been the way that systems have been modeled and built for a long, long time. And while it's a great way of storing this information, the way that we store it in third normal form is not necessarily the best way for reporting. Fundamentally, most of these systems where we record this data usually does not record history. There are some systems that there are audit trails and so on, but if a person writing reports against a database wants to know, well, where did my customer live 3 years ago, that's something that typically isn't recorded in the system of record. The system of record, for the most part, keeps track of, where does the customer live now. Obviously, that's where, as you're doing business today with that customer, that's where they live. It is a complex environment. It is a complex way of storing data, not for the folks that know third normal form, but for the business community, it could be daunting and overwhelming. Databases of this nature typically have hundreds of tables with relationships between these tables that, unless you understand the system and you understand the business applications, you'd be hard-pressed to figure out where all this data lives. So the idea is, I want to get this stuff into the hands of the business community. I want to get this information to the right people at the right time and in the fastest possible way. The purpose being that the organization has to prosper, be profitable, grow, and do this in a very agile way. And the way that they can do that is by empowering the users, by providing them access to all this information that we've been gathering. And I don't necessarily mean give them the transactional level of data so that they can go back in time and look at a particular invoice. The systems of records can do that. What I'm talking about is getting to this data and looking at trends and potentially predict future trends based on this information. If I'm spending half of my time trying to figure out how to get to this data, I have that much less time to go ahead and do something smart with the data that I acquired. So the whole point of building this data warehouse is to have that central repository where the business community can get at the information and do something smart with it. All right. So that said, let's talk about what a data warehouse is. It seems to be a simple question, but depending on who you ask, you are going to get a variety of definitions. And I've got a graphic here that basically shows just a few representations of data warehouses that I found simply by going to Google, typing in data warehouse and clicking on the image tab, and you see a variety of representations of data warehouses. So many definitions, depending on who you ask. Is there a right definition? It depends. You know, there are a variety of ways to tackle this thing. There are two thought leaders running around out there preaching and promoting data warehousing. Ralph Kimball and Bill Inman are credited with the beginnings of this movement. Our focus throughout this presentation and the series is Ralph Kimball. That's the approach that Done Solutions Group decided to adopt back in 2001, and that's what we've been doing since. All right, so let's define what a data warehouse is. In fact, the definition is quite simple. It's basically a system that goes and gets data or extracts data, prepares it, conforms it, and delivers it to a central repository in a dimensional way so that it can support decision support systems or decision processes. And basically the idea is that the data warehouse is a place where users go to get their data. You know that you have a successful data warehouse implementation if users are clamoring to get at your data warehouse to get the information that they need, and they certainly enjoy using it. A little bit tongue-in-cheek in that one, because we know that data warehouses that have been implemented over time don't necessarily always provide the best experience for their business users, but the idea is that that's what the goal is, and anything that we do is to move in that direction, and that should be what the goal is. All right, so I often get on my soapbox, and well, I don't actually look like that, but that's what I'm doing right now. I'm going to tell you what a data warehouse is not. And a data warehouse, it's not a product, not a language, or a specific project. It's not just a data model, and it certainly is not a copy of your transactional system. If you had this in mind as what a data warehouse might be, it's not these things. And sometimes it's easier to tell you what something is not rather than to tell you what it is. I will mention, though, that today there are products available out there that's a bundling of technologies and schemas and tools that approach what a data warehouse is. There's no such thing as an out-of-the-box data warehouse. There's always going to be some configuration and adjustment that you have to make to anything that you get out of a box. But the products today are getting smarter and more manageable and give you a big leap forward in developing your first data warehouse. So keep that in mind, that there are products out there that are coming close. All right, so when we talk about this series, I want to first introduce you to the BI stack. And the BI stack is basically a logical separation of the components that make up your business intelligence solution, of which most of revolves around your data warehouse. So I'm not going to talk much about the front room. I'm going to talk mostly about the back room in this series. And in this specific presentation, what we're really going to focus on is the presentation server. Don't confuse the presentation server with software to do ad hoc reporting and so on. Those are BI applications, as is shown on the box on the right. But the presentation server is basically the server where the schema that you are allowing users to get to is. And it's the final staged and prepared data that people can come to and consume. If you think about a cafeteria, and people come to the cafeteria line to pick up the food that they want, they certainly don't get to go behind that counter and go into the kitchen and mess around. That's all the backroom activities, and so what we're going to focus on today is that front room activity where we expose the data. In subsequent webinars, we are going to talk about more of the backroom issues and so on, but today's focus is that presentation server. All right, and that presentation server is all about dimensional modeling, and that's the main topic of our conversation today. All right, so what is dimensional modeling? And basically, dimensional modeling is a technique that allows us to look at transactional information and model it in such a way that it's easy to consume in a data warehouse. The dimensional model schemas are considerably easier to read and very appropriate for simple SQL queries. When I say simple SQL queries, I mean that the queries that you have to develop to get the information are considerably easier than queries against our normal form databases. So let's talk about the steps involved in doing dimensional modeling. And the first thing is to identify the business process. And once you've identified the business process, identify the grain or the level of detail of the data that you want. I'm going to talk more about grain in a little bit. We identify the dimensionality of the information that we're looking at. In other words, if I were to look at the data that I'm exposing in the data warehouse, how do I want to slice it up? And that's a good way of looking at dimensionality. We also want to identify the various facts or the measurements that we are taking to make up the components of our data warehouse. And once I've done all this, I'm ready to build my stars. Okay, so let's talk first about identifying the business process. And really identifying the business process is a combination of looking at what part of the business you want to measure, and then determining what are the requirements of what are we trying to do with that data and what is the data availability. Anything that you may want to measure or anything that you may want to do only makes sense if you actually have the data to do it. So that's part of the identifying the business process. Not only what we're going to measure, but do we actually have that data? And examples of a business process that you might want to focus on is sales activity, inventory, or student registration. These are business processes. Notice it's not about a specific piece of data, but about a transaction that may span multiple areas within the organization. The sales activities or inventory activity doesn't just impact one department within the organization. So we're not talking about stovepipes of data, but data that spans across various departments within the organization. All right. The other thing that we need to do in this data that we're going to collect and put in our data warehouse is identify the grain or the level of detail that we need. And the one thing I do want to mention, and I'll mention it several times, is we want to get the most granular data possible to put into our data warehouse. And the reason being is somebody will always ask, I want to get down to that detail level. And if you start modeling at a higher grain than the most granular data that you have, you will run into the problem where your data warehouse will not support that drilling capability. So while you may create aggregate pieces of information from your data warehouse, make sure that your fundamental data warehouse or your fundamental stars are grabbing the most granular piece of data that you possibly have available. All right. Okay. Now, once I've identified my grain, the next thing I want to do is identify my dimensionality. And really, identifying the dimensionality, and I like using the analogy of slicing through something with your knife. You have different kinds of knives that you want to slice with. And your dimensionality is the way that you would consider slicing up the measurements that you're taking to support the business process. So one of the ways to look at this is to say, when people are asking for data, what kind of selection criteria do they use? For example, they want to slice based on, or they want to look at the data based on specific genders or look for a specific gender. So gender could be a good dimension that could be part of your solution. Also look at the various row headers that you might see in a particular report, like the name of a college or the sales region or whatever the case might be. But these are good places to start looking at for what dimensions you may need to support. Obviously, completely understanding the business process will also reveal dimensionalities that you want to look into. So how do you want to slice up that data? That's what you're looking for. I do want to make mention that there is a component that's present in almost every data warehouse. It's the time dimension. The time dimension has been slightly renamed. People still call it the time dimension, but today we really think about the date dimension. There is such a thing as a time dimension. I'll get into this level of detail a little bit later. But basically, what you're looking for there is when did this thing occur? What period am I interested in? And normally in things that we do in most data warehouses, we're not really focused on a particular hour of the day. We're typically looking at something at the grain of a day. And so that's why the time dimension really is the date dimension. And there are situations where you might have a separate time dimension that talks about the hours of the day. The other thing to note is when we talk about dimensionality is that we are looking at conforming dimensions, and this is very important, and we'll talk about this later as well. But conforming dimensions basically means that whatever dimensionalities I do define, I get consensus across the organization that this is the definition of that dimension. If I am calling this thing a customer, that's the definition of customer, regardless of what part of the organization I'm talking to. Very easy to say, very difficult to do. All right. Now, you can't have a data warehouse without the metrics or the measures that you are recording, and that's what makes up the fact tables. And basically, these are the numbers that you're adding, that you're counting, that you're averaging. These are the measurements that you're taking. There are various flavors of these things called facts, counts and sums. They can be additive. That means that they actually add up across the various dimensions. They might be non-additive. There are some facts that you cannot add up across dimensions. They might be semi-additive, which you probably can guess is sometimes they're additive and sometimes they're not. And you also might have factless fact tables. So they're very interesting. It's a fact table that records no numbers, but does record the relationship between two dimensions. So those are important as well. And when we are talking about facts, we may have facts that are at the transactional grain, so basically the most atomic, granular measurement of that transaction. We might have periodic snapshot grain. Think about that as your monthly inventory. So at the end of a particular month, you want to know what your inventory levels were. So that's a periodic snapshot grain. At the end of every month, for a particular product, I'm going to know how many I had at the end of the month. You might even record at the beginning of the month and the end of the month. And then you also have the accumulating snapshot grain, which basically says for the lifetime of this thing, I am recording one number. And as an example, it might be how many of these things have I sold, period. And the accumulating snapshot grain is a number that keeps adding up. You've only got one row for the life of that particular entity. So for example, how many of these blue shirts have I sold? I will have a row for the product shirts for the color blue, and I'm simply updating that value. We'll talk more about those in a bit. All right, so now that I've got my facts and my dimensions, I put them all together into this thing called a star schema. And so you might ask yourself the question, and I suspect you're not, if you've been around data warehousing long enough, why the heck do they call it a star? And maybe because it looks kind of like a star, maybe. All right, I understand that really we're talking about a star topology, which is from the center we branch out outwards one level, and that is why they call it a star schema. I've got a fact table sitting in the middle, surrounded by dimension tables, and there's a relationship between those dimensions and those facts. I'm going to pause for a second here, and I'm going to ask Lori to do something for me, because normally I have somebody here to help me out with time.
Yeah.
Lori, if you please let me know when I am running out of time or how we're progressing on time, because I think I'm running a little long.
You got it.
All right, thank you. All right, a collection of stars is sometimes referred to as a constellation. You may have guessed that, but if you didn't know, that's what they do. So if I've got a schema with a variety of fact tables sharing dimensions, sometimes that is referred to as a constellation. All right, so let's take a look at this structure a little bit more closely. And what we're looking at here is the fundamental structure. I've got a fact table. It's just a database table, which is made up of primarily foreign keys to my various dimension tables and the various facts that I'm measuring. And likewise, in my dimension tables, I've got primary keys which make up the foreign keys that are being referred to inside of my fact table. Everything that's in that fact table has to be of the same grain, so any particular row that I'm adding into that table has to make sense across all the dimensions that I've got surrounding that particular fact. Fact tables are narrow in terms of the number of columns that they have, but they're typically deep. Comparatively, and we'll talk about this in a second, dimension tables are a little bit different. They are wide and relative and comparatively narrow. All right, so my dimension tables, as I mentioned before. Now the dimension tables, they do have a primary key. And on top, besides the primary key, the other thing that's important is they have very verbose and textual attribute columns within them. And so this is where all the descriptive or the color around the particular dimensionality is placed. One thing that's very important when we're talking about the Kimball approach to doing this is that we define surrogate keys for our dimensions. Now, what is a surrogate key? A surrogate key is a meaningless key. It's a unique identifier, usually a sequential number, that allows me to identify any row in my dimension table uniquely and regardless of what happens to the rest of the attributes within that particular row. The natural key that you might be thinking of also in these dimensions are keys that make sense. A natural key might be a customer ID number. So a customer ID number has meaning. It's the identifier for that customer, but sometimes customer IDs change, and that could wreak havoc in your schema if you start changing natural keys and you're relying on those as your mechanism for uniquely identifying rows within your database. Now, I do want to mention an exception. There is we don't always use surrogate keys. There's a dimension that we will talk about called the date dimension, and well, my school of thought is that you don't necessarily need to define a surrogate key for your date dimension. We'll talk more about that in a bit. So taking my little colorful, fake, or logical schema, I wanted to show you what a physical schema or physical model might look like, and you could probably guess if you've worked with database tables that you basically have the definition of columns that are keys and columns that are attributes of various data types. And so this is what one might look like. This is actually a good example of star. If any of you are going for an interview and ask you to draw a star schema, you can take this one and draw this particular one. It incorporates almost every component that will demonstrate to your future employer that you actually know what a star schema is. So you've got your fact tables with the various foreign keys, as well as the column with the particular metric, and some very common dimension tables, like a store dimension, a product dimension, and a date dimension.
Jose, probably a good time for a question we had come in about the difference between cubes and star schema.
Good question. Actually, in one of my future webinars, we're going to look at physical implementations of these things. A star schema is really a logical design, and a cube itself is a star schema implementation. Each of the sides of the cube is, in essence, a dimension, and the intersection of those dimensions is a fact. And so whether you instantiate your model as a relational star or as a cube, you're in essence doing the same thing in just physically a different way. By the way, oftentimes what ends up happening is that your data warehouse is based on a relational model of stars, and then from those stars, cubes are created and generated and populated for various tools. So certainly is a thing that you can do to combine the two. Thank you for the question. All right, I want to talk about the date dimension. It's my favorite dimension of all. And one of my interview questions, I ask people, so what's so great about a date dimension? Why do we need one of these things? And the slide that I have here has what people typically think about when they think about a date dimension. They think about this, this entity that describes a date or adds description to what normally is just a particular day of the year. So from a date dimension, the basic date attributes are things like, oh, what year are we talking about, what quarter, what fiscal month, what day of the week. These are all typical things that people think of when they think about the date dimension. And while those are useful, and the date dimension itself is very useful, they're not as exciting as some of the other attributes that you can associate with the date dimension. And I brought some of these here. So a date dimension starts getting interesting when I think about describing a date in a completely different way. Yes, I've got my fiscal year, I've got my calendar year, and so on. But what if I could tell you that a particular date was during high season, or during the winter selling days, or maybe it's a particular semester in a particular school year. And so that's when the date dimension starts getting very cool. So any fact that I'm recording, maybe I'm recording sales activity, I can ask, so how do my sales look during Thanksgiving break? So if you're thinking about a particular geography, and you know when school's not in session or off for a particular season, you could have attributes in there that tell you what seasonal time is going on. So you don't have to know that Thanksgiving is on this particular day. There would be an attribute that says Thanksgiving season, and it would be yes or no. Or there might be an attribute that says holiday, and it would tell you the specific holiday. So I don't necessarily have to focus on the name. I can also have information here about the way to describe this date in different languages. So I can have my English definition of a particular date, Monday, Tuesday, Wednesday, or I could have my Spanish definition, lunes, martes, miércoles, and have those all in that same database table. So you can do a lot of really neat things with the date dimension, and I want you to remember that. Not that that it's not just the calendar kind of date things. It's also very other very more descriptive attributes. Okay. All right, so let's talk a little bit about slowly changing dimensions, or SCDs. Slowly changing dimensions, there are 3 basic types, and there are hybrid types, but we're not going to talk about that today. The 3 basic types are type 1, type 2, and type 3. And I have to tell you, they're not the most descriptive names that you can come up with these things, but they do address a variety of situations. And I want to show you what these particular types are. Type 1, and actually, I should pause here for a second, because I realized that I said a slowly changing dimension without telling you what a changing dimension is in the first place. As I'm recording my dimensionality, sometimes things change. For example, if I have customers and the customer moves, the customer's address is going to change. And I want to record that. And sometimes I care about what my customer's address was before he moved. Sometimes I don't. Sometimes I care about a customer's address regardless of how many times they move. And I want to keep track of all that. Those are dimensions that change over time, and typically slowly change over time. People don't move every other week. They move it less frequently. And so what I need to do is figure out a way to deal with that. So my slowly changing dimension types give me mechanisms for dealing with that. So type 1 is the situation where I don't care about history. I just want to record the latest and greatest value. And so I'm basically overriding information in a type 1 slowly changing dimension. Type 2 and type 3 do history preservation. Let me tell you about type 3 first. Type 3 basically says I care about the current value and I care about some other value, maybe the first value or maybe just the previous value, but probably no more than that. So I may care about 2 or 3 instances in time. And in a type 3 slowly changing dimension, what I'm really doing is I'm simply adding additional columns into my dimension table and recording what that value was for a specific point in time. Type 2 is the one that's a little more interesting, and type 2 basically says I'm going to preserve all history. So every time that an attribute changes, I am going to record that change and also keep track of whatever the values were beforehand. So as values change, I'm inserting additional rows into my dimension table. And so when I have a customer whose address changes, I'll then have 2 rows in my dimension table for that customer. One is the current active record, and the other one is the historical record. And if they move again, I'll have 3 rows for that particular customer. And let's take a look at why that's important or how that works. All right. By keeping track of all the changes that occur for a particular dimension attribute that I care about, I have the ability to go back in time. And this illustration here that I have shows you how that works. Let's take a look at the first figure up on top, the one that says Figure 2, because Figure 1 was on the other page. I apologize for that. Figure 2 here shows me that I have 3 specific rows in a fact table. It doesn't matter what I'm measuring, it's some specific fact. And in my dimension table over to the right, I have 2 records that refer to a particular dimension. And in this particular dimension, what ended up happening is that the description changed. So it went from GHI to JKL. And I want to keep track of that. But I do note that as I'm recording these changes, my dimensional key, which is the dimensional key labeled 2, actually I think I can point here. Oh, there we go, right there. Let's do that. Refers to all the fact rows that pertains to this person. There are ways that I can indicate which row is my active row. I can do that with a flag. I can do that with expiration dates. But the point is that I always have the ability to see which is my current row and which is my historical rows. So now if I ask the question, what is the total amount of sales for this particular customer, I simply add up those 3 rows. Okay. Do I care about whether the customer, whether the description was this value or this value? That depends. If I care about historical reference to this customer and I want to see when it was GHI, it'll give me the rows in the fact table that were the transactions that I recorded during the time that that was the value. Down here what I'm showing is basically the same tables, except now if I only focus on the current, the here and the now, I am looking at this particular customer, and notice that that particular customer, if I wanted to know the values for customer JKL, I would get the sum of these 3 values, even though some of these transactions happened in the past. So this is the mechanism that a type 2 slowly changing dimension, this is how it works under the covers, and it's a very powerful tool for recording history as you're capturing transactions. All right. There's a bunch of other types of dimensions as well that we can talk about. We can talk about rapidly changing dimensions, mini dimensions, degenerate dimensions, junk dimensions, and outriggers. And really this presentation, as it dawns on me, is a presentation of terminology. And I'm throwing a bunch of terminology at you because these are things that the language that we have to speak when we're talking about dimensional modeling in a Kimball sort of way. So let's first talk about what a rapidly changing dimension is. A rapidly changing dimension is also referred to as a monster dimension. And basically what this is a dimension that changes so frequently that if we tried to do a type 2 mechanism for recording history, our table would grow astronomically to the point where it was almost unbearable and useful. And what happens is, if we look at the things that I talked about earlier, I've got dimensionality attributes that change infrequently. So if I'm recording history, I might end up in the example before where I might have 5 customer records for a particular customer over the span of years. And that's okay. My table's not growing that fast, and I'm tracking history. But what happens if I'm keeping track of history on a value that changes often, like flags or well, like flags, that's a great example, that maybe they're changing every day. Imagine if I had a customer table that I'm recording a particular attribute that every few days the attribute's changing. My 1 million row customer table in a matter of weeks could become 17 million rows, and in a matter of months could be terabytes in size. That's unmanageable from the point of view of hardware and of performance, and it's something that we want to try to avoid. So rapidly changing dimensions we cannot handle through the traditional type 2 slowly changing dimensions. So in this slide here, we talk about how can we address rapidly changing dimensions. Well, we do this with a technique called mini dimensions. And so the first image up on top here is my typical fact table, dimension table with my rapidly changing dimension attributes sitting over here. Now, we already mentioned that I don't want to do that. My table is going to grow too large, so what should I do? Well, the technique that Kimball recommends is to take these attributes that change frequently and make them their own dimension table or mini dimension table. And in fact, you're also going to do another thing. And this is not without compromise. There's issues with doing this, but it's a technique. You can take some of these rapidly changing attributes and create bands of information. So for example, instead of recording what every customer's annual income is, you might record what band their income's in. So people that make between $50,000 and $70,000 a year, between 71 and 100, 101 and 150, right? So now you have 3 distinct values for a particular data point versus every infinite potential salary that that customer might have. So between many dimensions and using a banded approach to recording some of this information, you can control or deal with the rapidly changing dimensions. There's going to be a presentation that we're doing in the future. I'm going to show how to populate some of these things and have demonstrations of tables actually growing. And this is one of the things that we will be demonstrating live. We'll actually run some ETL and watch the tables grow. All right. So I talked about the first two, rapidly changing dimensions and mini dimensions. Let me mention these other ones here. The degenerate dimension. A degenerate dimension, I tried to come up with jokes about this, but I decided not to. And so really what it is, it's a dimensional attribute that has no other description that you can say about it. And the best way to describe this is to give you some examples. A transaction number or an invoice number are examples of degenerate dimensions. It's a dimensional attribute that you store in the fact table as opposed to creating a dimension table for it. Because if you created a dimension table for it, that would be the only attribute in the dimension table. And why am I going to create a table with one column and join it to my fact table? So things like a transaction number might be something that you record in the fact table as an attribute as opposed to creating a separate dimension for it.
We're at the 15-minute mark.
Thank you. All right, junk dimensions. Best way to describe junk dimensions, everyone in their kitchen has a junk drawer. You got a bunch of attributes that you're not sure what to do with or where they go. You create a junk dimension, you dump them all in there, and you are at least recording these things in your data warehouse until you figure out something to do with them, or just simply use them within that junk dimension. And outrigger. Outrigger is the beginnings of snowflaking. I haven't talked about snowflaking yet, but I will in a second here. But an outrigger is an exception to the rule that you have dimensions and facts that are joined together. What an outrigger basically is a secondary dimension table that's referred to from a primary dimension table. And when we talk about snowflaking in a minute, you'll see that that's what the beginnings, what an outrigger starts. There are times and places where this is an important thing, important tool that you can use. I'm going to give you one quick example here. In my example here, I've got a human resource fact, whatever that I'm recording here, and I've got my employee dimension. And so one of the things that I might record about my employee is, you know, what skills do they have? I certainly don't want to put in a column into my employee dimension for every skill that they might have. I don't know how many skills in total I'm going to have, right? And I certainly don't want to keep adding columns as I come up with new skills that my employee might have. So what I might have is an employee skill group or an outrigger table that basically says, hey, I'm going to refer to this employee skill group from my employee table. There's my foreign key, which refers to this other dimensionality called the skill group. And so this describes my employee a little bit more than just what the employee dimension has, describes his skills. And notice it's not directly tied to this fact table, but it's going through a dimension. So an outrigger is a dimension to a dimension and helps describe other relationships other than the relationship you have between a fact and a dimension. All right. For those of you who recognize this picture, that just means you're as old as me. But there are three, when we're recording facts, there are three grains of facts that we worry about: the transactional grain, the periodic snapshot, and the accumulating snapshot grain. And so here's a neat little table that kind of lays out, well, what are these things used for? The transaction grain is one of the most common types of facts. You're basically recording every transaction, and it gives you point-in-time information. The periodic snapshot grain, we gave an example earlier. That's where I'm recording some particular measurement, but I'm recording one value for every period. Maybe it's my month-end value. So my periodic snapshot grain is month-end, and I'm recording whatever the month-end value was for that particular intersection of all the dimensionalities. My accumulating snapshot grain is another interesting type of fact table that I can define in my model. But what I basically have there is one row per the life of that particular entity. So if I want to record revenue I've generated for all time for a particular customer, I might have an accumulating snapshot grain table where that intersection of those dimensions tells me what the total accumulating amount is from the beginning of time.
Quick question around the difference between mini dimension and outrigger.
All right, that's a good question. Here's what I'll try to do. These questions that we're receiving, I'm going to try to come up with a paragraph-long explanation for some of these things because that is a question that does come up, and there is a distinct difference between the two. I just don't have time to get into it.
Gotcha.
But
okay, so for all our attendees, any questions that we're unable to answer during the course of the presentation or at the end, because we're short on time, we'll do our best to share the answers with you via email. Thanks.
Okay. So how do you make sure that your star schemas that you're developing don't end up being stovepipe data marts as opposed to an enterprise data warehouse? Well, it's not accidental. You have to make a conscious effort to make sure that you're dealing with or defining conformed dimensions, and you're also using what Ralph calls the bus architecture. So I first want to talk about the bus architecture, and here's a nice little matrix that describes what this is. The bus architecture is the Rosetta Stone for what's going on in your data warehouse. What you're basically doing here is you're identifying the various business processes that you are measuring that make up the various fact tables within your data warehouse. And then you're identifying the dimensions that exist within your data warehouse. So as you bring online additional business processes, you've got this little matrix here that says, well, how do I want to slice up that business process? If you want to slice it up via customer, well, guess what? You've got a customer dimension already, and you will reuse that customer dimension within this new star that you are creating. And if anyone needs to know, well, what are the dimensions that we have within our data warehouse? The bus matrix helps you communicate that and helps you keep track of and ensure that you are reusing the things that you have developed from the beginning of time. This is just a tool to help you get organized and a tool to help communicate what is in the data warehouse. You will be dealing with a variety of departments and a variety of people within your organization, and this tool will help them understand what we got and the way that we refer to, or the terminology we use within the organization. All right, there are embellishments is a good term for this. There are some embellishments, which we've mentioned some already. There's snowflaking, there's outriggers and bridges. What I wanted to do, and you're going to get these slides, so you'll have these points. I wanted to talk about snowflaking. And basically, snowflaking is taking a dimensional model and heading towards third normal form. If you are doing that, you should stop. However, there are sometimes exceptions to why you might want to snowflake. But the idea of dimensional modeling is to make a data structure that's easy to understand and performs very well for querying, and that's what the star schema gives you. Once you start snowflaking, you start turning into a third normal form data schema, and you are now dealing with multiple joins to get information that you wanted, as opposed to minimizing the joins between those tables. And I mentioned earlier that an outrigger is the beginnings of a snowflake, but sometimes outriggers are okay. And if you're dealing with low cardinality attributes, outriggers are cool. You can use that. Use it sparingly and use it when it's appropriate. Oh, by the way, why do they call it a snowflake? All right, fine. So that's because I remember the star. Why do they call it a star? Whatever. I tried to be funny. All right, just a couple more slides here. Dimensional modeling myths. And so I want you to print this slide, fold it up, keep it in your pocket, and look at it often, because these are things that folks who are not proponents of dimensional modeling will try to tell you that is a problem with dimensional modeling. And I'll highlight a few of them. And my favorite one is dimensional data warehouses are appropriate only for summary level data. That is certainly not true. It may be the case that you create aggregated fact tables within your data warehouse for specific situations and to improve performance, but your data warehouse better have that atomic level of data. You cannot create the aggregated information without the atomic level of data, and if you started with too high of a grain, you will get in trouble because someone is going to ask you for the details under the cover and you won't have it. So make sure that your dimensional data warehouse is, that the grain is as fine as you can get to it, and that's what you want to store, the atomic level. You are recording transactions after all. You're just recording it in a different way. Oh, here's a good one, second one. So dimensional models presuppose the business questions that are going to be asked, and so you're basically designing to answer specific questions, therefore it's not flexible. Absolutely not true. When you're defining these star schemas, what you're trying to do is record the metrics that are important to a particular business process. You don't even care what the questions are going to be. But these are the fundamental pieces of information that you will need to answer any question that somebody might have around that business process. Now remember, you also have to make sure that in your source systems or your systems of record, you are recording this information. But if you are, it should make it into your data warehouse, and thus you should be able to answer almost any question that you might want to with the data that's in your warehouse. Two more that I'll talk to. Bringing new source systems into your dimensional warehouse breaks it. Absolutely not true. We don't go from source systems into stars. There's plumbing that sits in between. There's staging areas and things that we use, mechanisms and techniques we use to prepare the data for the star. And we'll talk more about that in subsequent webinars. But the approach of doing data warehousing correctly gives you an infinitely flexible way of introducing additional information that you didn't have or systems that you didn't have before. So it's certainly it's just the opposite. And finally, people say that Ralph Kimball invented the terminology, facts, and dimensions. He did not. He even says so in his books. It was actually developed in the marketing industry well before we were talking about dimensionality within these star schemas. 10 essential rules for dimensional modeling. Well, I was telling you myths before. Now I'm telling you stuff that you should do within dimensional modeling. You can certainly read this yourself. And since we're running out of time, that's what I'm going to let you do. And I just want to quickly wrap this bad boy up and let you know that we have subsequent webinars that we are going to follow with. And some of the future things that we're going to do is we're going to look at the ETL process and basically talk about what happens with that plumbing that populates the star schemas that we just talked about. We're going to have some demos with that one and show some, obviously I'll have to show you some tools, but really what we're going to focus on is the role of an ETL tool and the techniques and things that we do to develop an ETL system. Stars in motion. Well, stars in motion is a cute way of saying I'm going to do demonstrations of populating stars with different scenarios, like type 1 slowly changing dimensions, type 2s and 3s. So we'll take a look at that. I also wanted to introduce this, not really data warehousing, but very tightly coupled, columnar and in-memory databases. So some folks might say, well, if I have, well, let me tell you, columnar and in-memory databases are really, really fast. So if I have these really, really fast databases, why should I bother doing these star schema dimensional models and writing all this ETL code to populate my stars? Well, there's a bunch of good reasons, but what we're going to look at here is how these technologies greatly improve the performance of any database, including the dimensional models that we designed. And finally, we're going to look at some business process modeling or stars specifically related to some business processes like retail sales, inventory, CRM, and HR. So we'll take a look at some schemas specifically designed around dealing with some of these business processes. And it might be a good starting point. If you're going to build one of these stars and you haven't built it yet, you can start out with these schemas and kind of go from there and get a sense for what kinds of things, dimensionalities and facts that you might have around these processes. So,
we have just 2 minutes left. A question came in that I thought you could quickly address. It's a good question. I have it myself. What's the difference between a data warehouse and a data mart?
All right, good question. Data marts are encompassed within a data warehouse. So a collection of data marts is part of a data warehouse. And by the way, you're going to get many definitions for this as well. But in your data warehouse, you will have a variety of stars for related business processes. You can consider those data marts, the ones that cover a particular process, and a collection of those data marts makes up a data warehouse. So basically, your very first star is a data warehouse and a mart. As you start adding marts, it's really a logical boundaries around these things. You are just growing your data warehouse. So that's one, and that's my favorite definition of the difference between a data warehouse and a data mart. Thank you.
Okay, we have some more involved questions that we were unable to answer with the time that we have remaining. So as I mentioned earlier, this presentation was recorded. We are going to share the recording with you as well as a copy of the slides, and we will do our best to address all the questions that were submitted and get those back to you by email. So thank you everyone for joining us today. We're so pleased to have you with us, and we look forward to you joining the next webinar in this data warehouse series. All right. Thank you, Jose.
Thanks, everyone. Have a good weekend.